Hi friends, welcome to SPJK Technosoft, your one-stop training and education platform. In this video you are going to learn about solenoid, magnetic field lines. This topic is from CBSE 10+2 Physics Syllabus, Chapter 4, Moving Charges and Magnetism. Topics covered in this video are, what is solenoid? Solenoid, magnetic field lines. How to calculate magnetic field strength inside a solenoid. Deriving expression for strength of magnetic field by using Ampere's law. In this channel you are going to learn physics from our subject matter expert Mr. Phani Kumar, who is having more than 15 years of experience in teaching physics. For engineering, diploma, CBSE 10+2 students and other competitive exams like NEET, IIT, EMCET, ECET, CBSE 10+2 exams. You will receive more updated videos on CBSE and other competitive exams syllabus videos, so do subscribe our channel and press the bell icon to get the new videos at your fingertips. Happy learning, viewers.
In this video we are going to discuss about solenoid. Let us start. First of all, what is solenoid means? Let us discuss about first is what is solenoid. Means here a current carrying conductor which is wounded like a spring shape, like this, with many number of turns. Let us consider in this I current is flowing and its length is L length. That is, length of the solenoid is L. In this current is flowing and it has N number of turns, capital N number of turns. Means we can understand that a copper wire, a current carrying wire which is wounded in a circular shape, a cross section is circular, this is called as actually solenoid. What will happen when current flowing here? When current flowing to this here, around this coil a magnetic field will be generated. Let us see what is the magnetic field here. Shape of the magnetic field. Usually suppose this is the solenoid in which I current is flowing, then whenever this is solenoid having two ends. At one end current will be in clockwise direction and the other end current will be in anti-clockwise direction. Where current is in clockwise direction, it behaves as a south pole. Where current is in anti-clockwise direction, that end behaves as a north pole. Means here here magnetic field is generated. Please see the magnetic lines here. We are representing with the dotted lines. This is the shape of the magnetic field lines here. Because of north pole we can represent it. They are entering into the coil and here they are leaving from the coil. This is the magnetic field lines in case of solenoid, especially at the center. Please see here, in the center of the magnetic field, here magnetic field is uniform. Means inside the solenoid magnetic field, if you take magnetic field is B, which is uniform, whereas at the ends its value is slowly decreasing. Means we can understand that here magnetic field lines are here. Magnetic field lines are less density. That is, the strength of the magnetic field is decreasing. Now if you calculate the magnetic field, there is an expression B is equals to mu naught small n into I. This is the expression for magnetic field in case of a solenoid. Now what is small n stands for here? Small n is equals to actually capital N by L. Capital N stands for number of turns and L stands for length of the solenoid. Here length of the solenoid. Then small n is called as number of turns per unit length. It is called as number of turns per unit length. Per unit length. Then how to measure this magnetic field strength? Let us see how to calculate this magnetic field inside a solenoid. Here once again, here we have taken a current carrying conductor which is wounded in a shape of a spring. whenever current I is passing through it, both ends of the solenoid, one end acts as a south pole and one end acts as a north pole based on the current direction. Suppose if it is current is anti-clockwise direction, it behaves as north pole. Clockwise direction, it behaves as a south pole. Simply we can say that solenoid acts as a bar magnet, because we know that the structure of bar magnet from the lower standards we have studied, which has north pole and south pole, a bar magnet. Similarly, solenoid also acts as a bar magnet. Now, let us verify how to get this expression. Actually, the solenoid's magnetic field expression obtained from Ampere's law. Let us see how to verify it. Here I have taken again the number of turns solenoid. Here for this we have to assume a rectangular shape. Please see this rectangular shape. Here rectangle I have taken, like this is an Amperian loop. Let us consider these names are A, B and C, D. Now here I current is flowing to the solenoid. Then if you observe this A, B, C, D along the sides AB, along the side AB, first of all let us take one by one. Along the side AB, in this side there is no current is flowing, means I is equals to 0. Now along these two, please see that these two and means BC and AD sides. Along BC and AD sides, magnetic field is perpendicular to the line element. Whatever that line element means, you can take a small length on the Amperian loop that is here. Whenever these two are perpendicular, theta can be taken as 90 degrees. Now by this use information, if you substitute in integral b bar dot dl is equals to mu naught into I according to Ampere's rule to calculate the magnetic field here. We see b bar dot dl here. B bar dot dl here means this is dot product. Whenever dot product is there, we know that a bar dot b bar equals to ab cos theta. Then if you substitute theta 90, the total value will become 0. Means there is no magnetic field along AD and BC sides. And coming to the AB side, along AB side also there is no current flowing. Then here I value, right hand side in this equation, I can be substituted at 0. Again total value will become 0. Then finally we are getting only, we can apply Ampere's law only along C to D. Please see. Here we are applying Ampere's law along B bar dot dl is equals to mu naught into I. Now again if you substitute here B bar is parallel to dl bar, when then theta equals to 0, then it can be written as B into dl. Now B we can take it out of the integration. We can write integral B into dl is equals to mu naught into I. Integral B into dl. What is integral B into dl means? Here you can take this value will be equals to B into dl will be equals to number of turns, means it shows the length of the solenoid. Here capital L it will takes and mu naught into I. Now for n number of turns we have taken, this can be multiplied with capital N, and right hand side we can multiply with capital N. Then B into L is equals to mu naught into I into L. You can understand dl is a small length element. Integration of small length element will give total L value. Then B into L equals to mu naught into I into N. Then B value. Now if you calculate B value here, here I am writing. If you calculate B value here, B is equals to mu naught N I by capital L. Here N into capital L can be written as small n, number of turns per unit length. This is about magnetic field strength in a solenoid. This can be obtained by using Ampere's rule. This is Ampere's rules. To know about the Ampere rules, please watch the previous videos we have. In that we have discussed about Ampere's law, Ampere's law and its applications also. Now here. Now what is the application of a solenoid? Actually solenoids are used in electromagnets. Now coming to the application part, they can use in electromagnets. In preparation of electromagnets means in industries they are using electromagnets, and in case of inductors also, meaning in AC circuits we are using inductor elements. we are representing with capital L. In that also we are using. Where in case of inductor, what is there is an expression for self inductance factor L. L is equals to, please note down, mu naught capital N square into A by L. This will be, you will learn in case of electromagnetism concept, chapter 6 we will discuss in the CBSE syllabus. Self-inductance concept, but in case of a solenoid there is a self-inductance. This is called a self-inductance. This is called as self-inductance. That is L is equals to mu naught N square A by L. What is A stands for here? The cross section area, whatever the circular shape we have taken. L is the length and N square is the number of turns in the solenoid. This is about solenoid. In the next video we will discuss about toroid. Thank you.
Thank you viewers for your time. Don't forget to subscribe our channel and press the bell icon to get latest trending technology and academic related videos. For any further queries, please reach us at info@spjktechnosoft.com. Please like, share and subscribe our channel. Thank you and goodbye.